blood, well, everything these days. But as we use that data, that's been a wild ride. We're going to take a quick trip through time from counting with our fingers to, to building the future of AI-powered insight. And we're going to show how our projects fit into that revolution. Arangspice. A brief history of data analytics. For centuries, data analytics meant basic counting and record keeping. Think clay tablets, like as you can see here. And suddenly we could do more, but it was still incredibly limited. We had early programming languages like Fortran and COBOL to help with statistical calculations. Then came a relational database in the 70s and 80s. SQL became the king, and we could finally organize our data into tables, structured questions, as you can have it. And in the late 20s and 21st century brought us business intelligence. Suddenly, even non-technical users could create interactive dashboards. But these were mostly looking backwards. Then the internet exploded. Social media, the Internet of Things, everything became connected. We entered the era of big data, volume, velocity. It just went wild. Traditional databases started to struggle. Think about it. How do you represent a social network while all its friendship groups and interaction in a table gets messy fast? Yeah, really messy. That's where graph databases come in. They are designed to handle relationship as first-class citizens. Instead of rows, columns, you have nodes, things, edges. It's a much more natural way of representing reward scenarios. And the growth, it's explosive. The graph database market is projected to reach billions of dollars in the next few years with a compound annual growth rate of around 25%. Just crazy. It's more than a niche now. It's become essential. But even with graph databases, we still face challenges. How do we combine the power of graph with natural language models or the large language models that we have as now? So we had RAG. RAG lets LLM pull in relevant information to give better answer. But traditional RAG often misses the connection. Instead of just grabbing the snippet, Graph RAG uses a knowledge graph to understand the relationship between information. This means more accurate, more complete, and more contextual answers. And we're taking it even further. We're building an agentic application. This isn't just about answering questions, it's about an AI agent that can reason, plan, act on the graph data. Think of it as a super smart analyst that can explore the data, find insight, and even make recommendations, all anonymously. So let's go into my project. This is a screenshot of the data that we are using. The Cynthia data set. So Arangspice is an application that analyzes patient data using GraphRag, and the power of ArangoDB with the power of ArangoDB and NVIDIA CoGraph. We use Cynthia data sets, which you can see the screenshot here, which represent a network of patients. A network of patients. So we could ask a question like, find the 5 most top influential patients with databases with diabetes in North Carolina. as our high-end overview as we have here, we install the dependencies. Yeah, we also leverage LangChain, the cool graph, then agent creation, the smart router, the smart query router, as you can see here. So let's keep that. And this is very important because the cool graph is the one powering, which is where NVIDIA comes in and is doing the work behind the scenes for Network X when we start running like the AI algorithm calculations. So let's go down to the query. Yeah. So this is practically one of entering like patient with diabetes in California, and to so basically what's the highlight, as you can see here, is the AQL query and the Network X analysis. So our agent uses the AQL to find the relevant patients, then use Network X and ideally could graph for GPU acceleration, which I've already, as shown, is already running like on the beneath to calculate centrality measures. This tells us who is the most connected within the network of patients with diabetes. But this particular synthesis data set is not complete, so we had to move things around. Like for example, for location, we had to generate, we process locations for patients in the graph. Yeah, and due to limited resources, I could not really generate most of those computations, but we could still continue. I could show how everything works together. Yeah, so even from our method of mixing the locations, we didn't get any patient with diabetes in California in this data set. But if they were in this data set, let's go back to, to the function that really does. We've outlined virtually the steps on how it does that here for the tool, for this particular tool. And this is just the beginning. We believe that agentic application powered by GraphRag and the future of data analysis, the use case is limitless. So from financial fraud detection, personalized medicine, cybersecurity, we are excited to be a part of this revolution, and we hope that you are too. Thanks for watching.